problem number 10 from our geometric sequence notes say find the indicated term of the geometric sequence with the following parameters. We have a sub 1 equals 12. That's our first value. We have r equals 0.75, which is our common ratio, and n equals 4. That's the fourth term that we're looking for. The formula that we were working with a lot yesterday was a sub n equals a sub 1 times r to the n minus 1. And the nice part about this problem is that we already have all the necessary information for us to finish this. When we look a little bit more closely, a sub 1 is 12. That was given to us in the problem. R is 0.75. That was given to us in the problem. And then n minus 1, well, n was also given to us. And when we go ahead and we type this into our calculator, we get 12 times 0.75 to the 4 minus 1. Then we get 5.0625. Now, it was nice that we were given all that information on this particular problem, but as we flip over to problem number 11 here, we're actually given the sequence, and it does specify that it's a geometric sequence on this problem. It says find the general formula for the geometric sequence. Sometimes the problems say geometric and sometimes they don't. And if they don't say which kind of sequence it is, we need to figure it out. Now, luckily for us today, it does tell us that, which means that we're probably still going to need our same formula here. But when we go back and look at this, what we see is our first value in the sequence is -6. To find the common ratio, what we do is we're going to take the second term divided by the first. 12 divided by -6. Or we can take the third term divided by the second. -24 divided by 12. Or we can take the 48 divided by -24. But every single time that we do that, we're going to get that value of -2. 12 divided by -6 is -2. We could type those values in our calculator as well. And all that this one says to do is it says to find the general formula for the geometric sequence. We don't know any other information, so we can go ahead and put this information into our problem, -6 and the -2 to the n minus 1. And now, with that formula, we can find any value in our sequence based on that. So if we wanted to find the 100th term in our sequence, then we'd put 100 in here for n. So that's what we were working with yesterday. And I want to flip back over now to the front page of your notes and look at just a little piece of the right side of your notes. So if you can flip back to the front page here. A geometric series is the sum of the terms of a geometric sequence. An arithmetic series is the sum of the terms in an arithmetic sequence. We need to be adding these together. And I'm going to skip over the examples and the non-examples and jump down here to the formula here. Again, the formulas will be provided for you. But you need to know in this particular case that S sub n means the sum of the terms in the geometric series. And the thing is, on this particular formula, the formula is valid as long as r doesn't equal 1. 1 minus 1 would be 0 in the denominator, and we can't figure out what the fraction value is when 0 is in the denominator. As we progress through this unit, we're also going to be talking about another way of writing the sum, and it's with what's called sigma notation, S-I-G-M-A. And a sigma symbol looks something like that. So I'm told that some people have some familiarity with that and some of us do not. But we'll deal with that later on. So as we flip our paper back over to where it says geometric series examples, sorry about all the flipping. What's going to happen is, if you have it, if the first term is 1 and the common ratio is 2.5, find the sum of the first 13 terms. Well, once again, what we might want to do at the top of our paper is we might want to write down what that formula is. The S sub n equals a sub 1 minus a sub 1 times r to the n divided by 1 minus r. Just because you don't want to flip back and forth more than you have to already today. And it says again, if the first term, that means this time that a sub 1 is 1, and our r is 2.5, it says find the sum of the first 13 terms. What's 13 in this problem? It's the n. So now we can see the formula up here. A sub 1. So we want to find our sum. We're going to add all these values together. So we're going to have 1 minus 1 times r. And I would recommend using parentheses, even though the parentheses weren't written particularly in the equation. But it's especially important if our common ratio is negative. So I'm going to put it in parentheses. 1 minus 1 times 2.5 to the 13, there's our n, divided by 1 minus 2.5. Just a word of caution. If you don't have a fraction button on your calculator, then you need to put parentheses around the top of the fraction and parentheses around the bottom when you type it in. But if you do have a fraction button, I recommend using it. And when we do on here, it's alpha y equals number 1. And then we're going to type in that value. 1 minus 1 times 2.5 to the 13th divided by 1 minus 2.5. And that's going to give us our value here. If we add those first 13 terms of our geometric sequence together, we will end up with, put it down a little bit, maybe scoot it over a little bit, there we go. We will end up with 99,340, and I'm going to round it to the nearest hundredth. 2 decimal spaces. So not too much difference from what we've been working with regard to our arithmetic sequences and series. And if we take a look here at this next one, we're actually given the geometric series, and it also does specify that it's geometric, so that's helpful. But what we can identify in this problem is that our first term is 2. We need to identify what's our common ratio. And once again, to find the common ratio, we're going to take the second term divided by the first, the third term divided by the second, the fourth term divided by the third term. Well, 6 divided by 2 is 3. 18 divided by 6 is 3. 54 divided by 18 is 3. The last part here says find the sum of the first 15 terms. What's that? N. Now, hopefully you have the formula written there on your paper. I don't have it in front of on here for me, so it's A1 minus A1 times R to the N over 1 minus R. And we can fill that in, and we get 2 minus 2 times 3 to the n 15. Divided by 1 minus r, which is 3. And again, if you don't have a fraction button on your calculator, then you need to put parentheses around the entire top and the entire bottom of a fraction. So we type it in. Alpha y equals number 1. And then it's 2 minus 2 times 3 to the 15 divided by 1 minus 3. And we get that value there. And if you've been keeping up with your work, you're probably familiar enough now with finding these values. If we can identify what the first value is, if we can identify what the common ratio or the common difference is, if we can identify what n equals, then we can find our value. Okay? We'll talk later. But it's, for some reason, it's putting it in scientific notation. But I'm gonna skip over here because if you go back and do problem 3, problem 4, problem 5, you're gonna find that it's just a matter of identifying what the common ratio is and what the value of n is, and then doing the exact same formula that we did on 1 and 2. So I think it'll be a little bit better for us if we try to apply our formula a little bit more than just doing the same thing over and over and over again. And so it says, in a geometric series, the common ratio is 3, and S sub 4 equals 200. And the thing about S sub 4, what it means is, it means the sum of the first 4 terms is 200. And then it says, find the first term of the sequence, and we need to show our work. So let's write down what we know. We know that our common ratio is 3. Tells us. We know that the sum of the first 4 terms is 200. And if we go back and look at our formula that we're going to be using here, I gave it away, but it's S sub n equals A sub 1 minus A sub 1 times r to the n. And I've got to write down the formula right, but it's 1 minus r. 1 minus r in the denominator. What does n equal in this problem? You should be able to show me on your fingers. S sub n. S sub n. N is 4 in this problem. So we're going to have to work backwards here because we want to find the first term. We don't know what A sub 1 equals. But we're going to put our values back into the formula over here. And what we've got? We've got 200 equals A sub 1 minus A sub 1 times r, which is 3, to the n, which is 4, divided by 1 minus r, which is 3. And we can simplify this a little bit. 3 to the 4th. 3 to the 4th is 81. So we've got 200 equals A sub 1 minus A sub 1 times 81 divided by 1 minus 3, which is negative 2. Our goal is to solve for A1, A sub 1. So let's multiply both sides of this equation by negative 2. And we're multiplying both sides of the equation by negative 2. We get negative 400 equals A sub 1 minus, I'm going to write it just in a little bit different order. A sub 1 times 81 is the same thing as 81 times A sub 1. These negative 2's cancel out. Negative 2 divided by negative 2 is 1. And now we're in a good place here. But my first question to you is, what's the number in front of a sub 1? Nice. And you couldn't see that on the video, but people showed me that it was 1. And what we have here is we have like terms. This is 1 a sub 1 minus 81 a sub 1. And 1 minus 81 is negative 80 a sub 1. And that equals negative 400. And as we finish here, because we want to find our first term, it's negative 80 multiplied by a1. So our inverse operation is to divide by negative 80. And when we finish, we get a sub 1 equals 5.